uh, we are going to look at example 12. But before example 12, I want to respond to example 10 part B, which says, hence find the set of values for which 12 plus 4 is greater than x squared and 5x minus 3 is greater than 2. This is the solution for example 10 and part part A rather, and we are supposed to have solved this inequality. So the solutions to this is here. X is greater than -2 and less than 6. It is this part we need to solve, whereby this gives us 5x is greater than 5. And this tells us x is greater than 1. So if we have the two solutions to the two equations, to the two inequalities rather, we have to present them on a number line. The first one, -2 is not included, so we don't shade that circle. And the 6 is not included. We have something like that. Our values of x are valid between when x is between -2 and 6. Both boundaries are not inclusive. It is the second one we must now put on the same number line, and x is greater than 1. You realize that x does not have any upper limit, so it can go as far as it wants. Now, when you look at this number line, we need to select a region whereby both inequalities make sense. And it's just between this 1 and 6. Between this boundary and this boundary, where x is greater than 1 and less than 6, it is within this region where both inequalities are true. So the solution to part B is simply that. Note that we have ignored from 1 down to -2 because only one inequality is satisfied there. But between when x is equals to 1 to x being equals to 6, both of the inequalities are satisfied there. After that, now we need to go to example 11. We need to get to example 11. And example 11 is asking us, find the set of values for which 6 over x is greater than 2. And x is not allowed to be 0. You realize that when x is 0, this particular term, 6 over 0, is not going to be defined. It's actually infinity, it is undefined. So x cannot be 0. And therefore, with this kind of an equality, we have to be very careful, because we know from some previous videos that anytime we multiply an inequality or divide by a negative number, the inequality automatically reverses. And because we don't exactly know the nature of x, it could be negative, it could be positive. We are not allowed, or we are not going to multiply by x on both sides. Because if x is negative and we did not know it's negative, then we are supposed to automatically reverse this inequality. So what do? Of course, we need to multiply both by a number which we are very sure is positive, and that number is simply x squared. So x squared, whatever the original x was, we are very much assured that x squared is positive. So multiplying both sides by x squared, we have 6 over x greater than 2 by x squared by x squared. And of course, we are going to have 6x is greater than 2x squared. And that gives us something like that. And of course, if we talk of 6x minus 2x squared is supposed to be greater than 0, we can of course now get what is common outside. X is common, and if X is common, we can, if in fact 2X is common, 2X, then we have 3 minus X. 3 minus X is greater than 0. Assuming this is one bracket, then we can say 2X can be equal to 0, and if this is true, X is 0. This is one of the critical values. 3 minus X is equals to 0, and if this is true, then X is equals to 3. And we're talking about the two critical values. So if we may have to construct or to sketch a quadratic graph here, we are going to talk about 0 as one of the critical values and positive 3 as one of the critical values. But before we can sketch, we have to examine the nature of A, because A is the coefficient of x squared, which is less than 0, and the shape is obviously an n. What does that mean? After we have sketched this graph, we need to revisit our inequality. So what kind of values are we looking for? We are looking for values that are greater than 0. That means or above the x-axis. And those values where y is greater than 0, you can see if we can really use red color for that. That is the region we are talking about. And if that is the region, it is a continuous region. So for this kind of situation to make sense, x has to be greater than 0, and the same x has to be less than 3. You can see, as x is less than 3, then y becomes positive. And when x is greater than 0, then y becomes positive. And because it is a continuous region, then we can combine the two inequalities to make a compound inequality, that x is greater than 0 and the same x is less than 3. It makes a lot of sense. So any value of x between 0 and 3 satisfies this inequality, because within that range the y is positive. But remember, the lower limit, which is 0, and the upper limit, which is 3, both are not inclusive, because we don't have greater than or equals to. So yes, this is the final submission as far as that example is concerned. All right.